Xavier, go ahead and read the function listed.
The functions listed on the left can be differentiated without using the chain rule. And those on the right are best done with the chain rule.
All right. So I'm going to elaborate what this basically means. So if I look at the first one, x squared plus 1, we can differentiate this no problem because nothing is wrapped up on top of it. But on the next one, I have a square root wrapping everybody inside. Then if we have to use chain rule. On the next one, we just have our single x. Do I have a single x on this one? We have something embedded within, so we have to use chain rule. And then on the next one, we have something to the power of 5. So again, it is all chunked together to another operation. And then for the tangent, we have this guy right here, squared as well within, so we have to use chain rule. So let's go ahead and look and see how we can go about it. So in general, chain rule is done in layers. We do one layer at a time. It is done in layers. I see somebody on their phone. Hopefully they'll stop. Yep, they stopped. And by layer, here's what it basically means. Let's circle the very, very inside of our composition function right here. So what's happening is we're deriving the outside, keeping the inside as it is, and then deriving the inside. If that was confusing, I get it. Let's do an example like it. So let's go to example number 1. And on example number 1, and I want you guys to try to use a highlighter if at all possible. Underline the inside that we are not going to mess with since we want to derive in layers. So let's write out h prime of x. So on the very outside, we have power of 4. What did we do when we were finding derivative with the power? We brought that to the front. And what I have inside, I am going to leave that exactly as it is. Do not touch it. But the power becomes 1 less, so I have power of 3. And then what's going to happen is I'm going to highlight the inside that I did not mess with, and then say, now it's your turn to derive. What is the derivative of 5x? 5, and that's it. That is how easy chain rule is. Start with the outside, keep the inside, derive the inside, and we're done. Here's how it's going to be presented on a quiz. Listen up. And if you took on-ramps, and it might be kind of similar process, the way I'm going to answer it is the following. I'm going to have a skeleton model with all the letters that represent a specific number. And this is specific to this question. So if I ask you, what is A, you put in 4. What is B, you put in 5, C, 2, and so on. All right? Okay. Cody, you had a question?
So you could just leave the answer like that?
Yeah, you just leave it like that. Now, if this were to be a multiple choice on the AP question, you would take a coefficient 4 and the 5 and multiply them and make it 20 of the value, but I'm not going to worry about that piece. So let's move on to the next one. Number 2. We want to rewrite this so that we have it as a power. So let's write the inside as it is, power of 1/2. And let's highlight the inside that we're not going to mess with until the very end. I hope everyone's writing with me. So we have h prime of x. So what do I do with this power? Bring it down. Then we keep the inside as it is. 1 less than that fraction is negative 1/2. And then we are going to derive the inside that I'm going to highlight just so that I'm keeping track of. So we have x squared. What's the derivative of x squared? Oh, did y'all realize I wrote the wrong thing? That was actually cubed, right? So x cubed is now how many? 3x squared. And that's all you need to do. And I'm going to go ahead and skip to number 6 so that we're in the same category. Let's all go to number 6. We want to rewrite the denominator as a numerator with the power. So I have 2x plus 1, the power of negative 1. And again, underline the inside that we're not going to mess with. So our derivative, h prime of x, is equal to, what do I do with this number right here? bring it to the front, and 1 less than that is -2. And then take the derivative of the inside. What is a derivative of the inside? 2. And that's it. All right. Go ahead and take out the card. That's got your derivatives. I believe it was card number 2 on the back. If you want to use it, take it out. If you want to look at mine, here it is. So finding derivative of sine and cosine, I told you guys about snow cone, so that shouldn't be a problem. So I'm leaving that out for the purpose of number 4. Well, let's do number 3 first. On number 3, which is a chunk that I'm going to underline to not mess with? 6x. So I have h prime of x. So derivative of cosine, what is it? Negative something. Negative sign. You keep the inside. And then we are going to derive the inside, which is how many? That's it. So make sure you have your 6 trig functions memorized. Let's go on to number 5 next. On number 5, which is a part that I'm going to underline to keep as it is for the beginning? Sine of x. So let's write out. We have h prime of x. What is a derivative of cosine? Negative sign. You keep the inside, sine of x. And then let's go ahead and underline that inside to derive. What is a derivative of sine of x? Cosine of x. Hopefully y'all have more room. Okay, here is a common mistake. Some people are going to see negative sine of x and think about the following. So write this on your side for me. So going back to pre-cal or even geometry, when you were presented sine of x times sine of x, how many identical pieces do I see right now? 2. So you would say sine squared of x. But look what I have presented to you on number 5. Is this sine of x times another sine of x? This is sine of x and then that value of the negative sine of that value, meaning it's a composition of function. You leave that alone. So do not look at this and go, oh, imaginarily put an x at the end. Don't. Okay? This is composition of function. This is basically product. Function within a function. So now let's go to number 4. On number 4, let's write out h prime of x. If you have your card, and I'm going to put it right up here, we know we're going to be using this guy right here, cosecant of x. So starting with the underlining in the inside. The derivative of cosecant is negative cosecant and cotangent. In that parentheses is whatever the value that I'm not messing with. Which one am I not messing with? X squared. And I'm only going to underline the x squared on one of them, because really in the end, you're deriving only that one value in the inside. So what is the derivative of x squared? 2x. All right, listen for a common mistake. Students look at this and go, okay, I see that there's a derivative. And then they go, there's 2 of them. Do I need 2 of them as well? No, you're only deriving the inside once. All right? It just happens to be that the derivative of cosecant was 2 different trig functions. So let's go on to the back. Last page. Oops. On the back, let's do 2 or 3 that looks different than what we just did. Is number 7 pretty much something that I've already done on the front? Example number what? Example number 2. Thank you. So I'm not going to do that one. We did some with the trig. I don't want to do that one. How about we practice one with the root 3? All right. So we want to rewrite this. We have 4x to the power 5 minus 7x squared to the power of 4/3. The root goes in the denominator. The power goes on the top. So let's start by underlining the piece that we're not going to mess with. And if you don't have highlighter, at least underline it with a pencil. Yeah? F prime of x. So what do I do with this guy right here? Bring it to the front. Keep the inside. Minus 7x squared. 1 less than that is 1/3. And then we're going to multiply it by the derivative of the value that we didn't mess with. What is the derivative of 4x to the power of 5? 20x to the 4th. And then derivative of negative 7x squared. Very good. And that's it. Should be getting better and better. Okay, I want to do number 11 and 12. 11 I'll do at the end. 12 first. Okay, on number 12, not only do I have a chain rule, do we also have the x's separated pretty much with the product rule? So I think I'm going to go ahead and rewrite this. I'm going to rewrite it as x to the 1/2. And then the second piece, just copy as it is. It's already in the power form. So I see a product because the first component has an x in it, and our second component also has an x in it. So here's a reminder for the product rule that's going to be also helpful on your test today. The product rule states you derive the first one and keep the second one, yes? Separated by a plus sign, you keep the first one and derive the second one. So here I go. Our h prime of x. What is the derivative of x to the 1/2? 1/2 x, and then 1 less than that is negative 1/2. And we keep the second one separated by a plus or minus. Plus. And then we keep the first one. And then we derive the second one. And notice our second one happens to be a chain rule. So because I'm thinking ahead, I'm going to make a bracket because later on we're going to need parentheses. So we bring the 4 down. We keep the inside as it is. 1 less of the power is 3. What is the derivative of the inside right now? 5. And again, I see parentheses. So I'm going to close it with a bracket, and that's it. 9 or 11, we have a product rule or quotient rule. And y'all remember what went on the bottom? It was something all what? Squared. And the only difference about the product and the quotient rule was on the numerator, we had it separated by what sign? A minus sign. Very good. So we're going to derive the top. On the top, it is a chain rule. Derivative of cosine is negative sign. And I'm going to put a bracket because I know I'm going to need a parentheses at some point. We keep the inside. And then we take the derivative of the inside, which is this guy right here. 6. And I'm going to close it. We keep the bottom. Oh, I had enough room. And on the next piece, we keep the original. And we simply derive the bottom. The derivative of 2x squared is how many? 4. And